Here we are going to discuss thinking skill technique called compare-contrast, which you probably have used all the time without making it explicit. The idea is to compare two concepts or two objects, and what you ask is in what ways are they similar, in what ways are they different, and which similarities and differences are significant, and what conclusion is suggested. Now, remember that when we introduce this to our students, the first time we do this, and only the first time, we'd like to take an example from real life that the audience easily comprehends. So when I do this for my boys' classes, I compare two cars. And when I do it for my girls' classes, I compare two designer bags. And I'll ask the students in what ways are they similar, how are they different, and what similarities and differences are significant, and what is learned and you hear. And right after this idea of compare and contrast sinks in, I introduce the math content. Even as early as section 1.1 of Math 1, there's a great opportunity to illustrate and make use of this technique. We always ask the students to graph and list discrete subsets of real numbers, or graph and use interval notation to describe intervals of real numbers. So the example I'm going to use is this one. Graph and list all natural numbers between 1 and 5. Compare contrasted with graph and use interval notations on all real numbers between 1 and 5. And I elicit from the students the similarities, of course, between 1 and 5, and the differences. Similarities also both have graphs. Differences, one is list, one is use interval notation. And of course, these are very significant differences. And then I go to the difference that one of them is the set of natural numbers and the other one is the set of all real numbers. And we can compare, contrast then the solutions, and when you put them side to side, the differences are striking in that in one there's, when you list it, of course, the numbers 1 and 5 do not appear, and when you use interval notation, the numbers 2, 3, and 4 do not appear. So they're completely different solutions, and as we grade the exams, we have seen over time that there's always confusion between these two ideas. So this is a very valuable place to make use of compare-contrast for enhancing student understanding. Another place in Math 1 or Math 2 is to compare-contrast graphs with equations and ask the question of point on line. And there it's clear that the question when it comes to the graph is trivial, point on line, you look at the point and look at the line, whereas the equation version of point on line needs some technique. Namely, you have to substitute the x and y and see if you get an equality. And this is an important concept, and you'd be surprised how many students don't know how to do this. Another place where you can use compare-contrast is oftentimes, for example, in Math 2, examples follow each other that are very similar. So for example, here we have factoring trinomials as the title of example 2 and the same title for example 3. But the big important difference is that in the first example, the trinomials are ordered, and in the second one they are not. So that brings out the importance of ordering the trinomials before doing anything. In Math 4, we can use compare-contrast to distinguish between graphs or expressions involving absolute value and square. So we can do that, and that really enhances understanding of the students. And in fact, when you draw the graph for a parabola, there's always the question of the vertex. But for the absolute value, there's an equivalent notion of the vertex, which I call corner. Now, for the vertex, we have formulas for getting the vertex x coordinate of the vertex, but no such formula is evident for absolute values. Only when you make this compare-contrast, you see that you need to pay some attention to the corner of an absolute value exactly the way you pay attention to the vertex of a parabola. Also, oftentimes when students draw the graph of a parabola, on the vertex they draw a corner, which is wrong. So by bringing this compare-contrast, they will see that the two ideas are different, so that you do not draw a corner when you're drawing a parabola.